Now let's look at some past questions or example questions in physics. And the topic we want to concentrate our mind on is speed, velocity, acceleration, and equations of motion. Right? So we have about 6 questions, and we explain these 6 questions. Now for each of the questions, I'm going to explain. I'm going to what change values. Then you should what solve those questions using your own values. Right? That makes you understand the stuff the more. Right? So please, if you are here and you have not subscribed to the channel, please kindly subscribe. Hit that subscribe button, because if you don't subscribe to the channel, you will be missing out on every video content I drop on this YouTube channel. I create math, chemistry, and physics, and I also create content for you to be able to become a better student, how to study effectively, how to become a better student, and all of that will be of help to you in your JAMB preparation. Right? So let's focus our attention here. Now, this topic I've already done intensive classes like kinematics. I've done kinematics 1, kinematics 2, kinematics 3, right? So by the time you finish watching this video, go to the description below and you see those videos. Those videos are free, right? Those videos are free as the time of me recording this video, but in the future it may not be free. But for now, it's free. Probably when you meet this video, if it's not free, then you have to join my membership. But I will advise you to go check out this video now, because I believe it is free. But if it's not free, join my membership. When you join my membership, just like a way of you supporting this YouTube channel, right? While you also benefit from the exclusive content. Please don't always hide your question. If you have any question, always leave it at the comment section. So let's cover the first one. You see that a man runs a distance of 10.0 kilometers in 5 minutes. What is the average speed? So they say, what is the average speed of the man, right? Now we talk about this one is under this ability here is kinematics 1, right? The link will be at the description below, or just say you need the video, you need the link to this one here, and I will send you, right? So we talk about average velocity. We talk about velocity. Sorry, we talk about speed. Remember, speed and velocity have the same formula, right? But speed uses what? Distance over what? Time, right? And velocity relate what? Displacement over what? Time. It's okay, displacement over time. Now distance, there's no specific direction, but this one there what? There's direction. So the difference between speed and velocity is what? Distance and what? And displacement, right? So now if you look at the question here, they say that a man runs a distance of, so they gave us remember, I'm managing this board, right? I'm just trying to manage this board. I'm just trying to manage this board here, right? So if you look at it very well, please pay close attention here. If you look at it very well, then the question gave us distance, which is distance D is what? Is 10.0 kilometer, right? Then my time is what? Is 5 minutes, right? Remember speed, when we talk about speed or the average because of what? Distance D over what? T, right? So if she imputes the values here we have what? 1.0 kilometer over what? Here we have 5 minutes, right? Please pay close attention here, 5 minutes. So if you should do your calculation, here we have 1.0 divided by what? 5. Here we have 0.2. So here we have 0.2 kilometer per minute. The unit here is called kilometer per minute. Please pay close attention. Is what? Kilometer per minute. But here you must express it in meter per seconds. Do you understand? So it is saying that these values you must convert them. So you must convert kilometer to meter and minutes to what? To seconds, right? So let's do the conversion. Then we have to subtract our value again. So that means we have to do the word conversion. So now kilometer here for to convert kilometer to meter, you have to what? Multiply by 1000, right? So here you go to do what? 1000 times 1 you got to do what? 1000 meter, right? Then for it to convert minutes to seconds, you have to multiply by what? 60, right? Then for it to convert hours to what? to seconds, so you have to multiply 60 times what 60. So now you multiply it what by 60. If you multiply it by 60, 5 times 60, 5 times 60, here we have what 300. Here we have 300 what seconds, right? So from here now let's apply a formula here. So speed equals to what distance over what time, right? So my distance is what on the 1000 meter over my time is 300 what seconds, right? So let's divide it here. So here going to be 1000 divided by what 300. Here we have what 3.33. So the answer is what 3.33 watts, 33 watts meter per second. What's the option here? The option here is C. Do you understand? So now let us say here we have 6 and here we have 7. Go ahead and read some for me. Drop your answer at the comment section. Please always drop your answer at the word comment section. That is please always participate in this class. When I say drop a question, pause the video and solve the question, make sure you do that. That is the only way you can learn. Now you learn when I solve and I give a question for you to solve, and you solve it and drop your answer. That's what makes you to understand the more. Do you understand? So you pause the video if you don't understand it again, if you don't understand concept, pause the video, go by it again, then go by it again, then watch video, then you replace my value with this value here and drop your answer at the comment section as easy as that. Do you understand? So I'm going to wipe this place here now because we are done with question 1. So you can copy question 1 or pause the video, copy question 1 and solve this first question. Let's have question 2. A train with an initial velocity of 20 meters per second is subjected to uniform deceleration of 2 meters per second square. The time required to bring the train to complete as is. But now let us solve it here. You don't understand the English I'm speaking, or probably I copied the wrong question. I didn't copy it very well. So look at something. This is under equations of motion, right? And we have 3 main equations of motion. If you have checked my video, they're going to be kinematics 2. If you have not checked out that video, please kindly check out that video. Is it kinematics 2 or kinematics 1? That kinematics 1 or kinematics 2, right? Now, a train with an initial velocity of 20 meters per second is subjected. So a train with an initial velocity, right now, whenever I talk about initial velocity, I talk about u. So u is what 20 meters per second, right? Is subjected to uniform deceleration. Now, deceleration is what negative of acceleration. Pay close attention. Deceleration is what negative of acceleration. Acceleration is positive. Deceleration is what is negative. Hope you understand. So that is my A is what going to be what minus 2 meters per second square. Now, once you see deceleration is minus, right? When you say acceleration is what it's positive. Hope you understand. Now, the time they're asking you about the time. What is the time? It's okay. What is the time? What is the time required? So now let's know what the equation for motion we are going to use. So since I talk about the time, here we have. So let's use the first one here. We have 3 equations of motion. The first one is what v equals to u plus at. That was the first one. U plus at. The second one is x equals to ut plus half at squared, right? Then the third one is what is v squared equals to u squared plus 2ax. Now, these two have distance, right? So there is anything about distance here, so we cannot use these two. I'm going to use what the first one. So the first one I'm using v equals to u plus at. Just now, if you check very well, they didn't say anything about final velocity. They didn't say anything about final velocity. Now, because they didn't say anything about final velocity, my final velocity is going to be 0. So then you go to v equals to 0 meter per second. Is it okay? 0 meter per second. So we are using this formula here. Hope you understand. They didn't say anything about, because from the 3 equation of motion we know. Now, the 2 have distance. 2 have distance, but 1 don't have distance. So I want to use the one that do not have distance. So the one that do not have distance is what v equals to u plus at, right? Now my initial velocity is here. My v we are not giving, so it's going to be 0. Do you understand? It's going to be what? 0. Now, so how do you solve it here? So let's substitute what our values. So it's going to be 0 equals to what? U is what? 20 plus. Remember there's plus here, right? Plus here. Then remember this here, these two I'll put in bracket. Why? Because there's minus. So it's going to be minus 2 times what? C. Can you see that? So it's going to be 0 equals to 2 plus bracket up minus 2 times what? C, right close, right? So when you look at it very well, it's going to be 0 equals to plus times minus is what? Is minus. So it's going to be 20 minus 2c. Can you see that? Now can you sort to that point here? You have minus 20 equals to minus 2c, right? Divide both by what? By minus 2, minus 2, minus 2, right? So this minus cancel out this minus here. 2 going to 20, which is what? 10. So you have c equals to what? 10 seconds. Hope you understand. It's very easy. This stuff is very easy. So now the answer is what? Is 10 seconds, which is B. B is what is correct what option. Now let me change the value. Now let's say we have 25 meter per second, right? 25 meter per second. And let's say the acceleration here. Now let's say we have what? 5, right? So go ahead and solve this question for me. Pause the video here. Use the value I've used, then drop your answer at the comment section. Very, very important. Try solve this one here, please. For every question I say try, please make sure you don't ignore that question. There are students who procrastinate what they are going to do. Now they are watching this video here. They are watching this video, but they'll tell you that I will do it later, right? And there are over 8% of the people watching this video here. They say I will do it later, but later we know that you will not do it, because why? Later you go and watch, or you have other things you are to do. So the best time to do anything here is that as I watch the video, please kindly engage with the video. And how do you engage with the video? Is by what? Liking, subscribing, and drop your question and answer at the comment section. This is what best way to learn, right? So I've changed the value here, right? So the question is what? A train with an initial velocity of 25 meters per second is subjected to a uniform deceleration of 5 meters per second squared. The time required to bring the train to complete is, do you understand? So you have to solve this question yourself, right? So we are done with question 1, we are done with question 2. So I will just wipe it out. So now let's look at question 2. Please pay close attention here. Question 3. Let's look at question 3. A body accelerates uniformly from rest at 3 meters per second squared. So the acceleration, right? A body accelerates uniformly from rest at 3 meters per second squared. Its velocity after traveling a distance of 24 meters is. So they're asking you the velocity after it travels a distance of 24 meters, right? This question is very easy. So yeah, they say a body accelerates uniformly from rest. So immediately you say this rests, that is my initial velocity is what? 0. When I see rest, my initial velocity is what? 0. So here we have u is equal to what? 0 meter per second. 0 meter per what? Per second. So my acceleration here A is what? My acceleration here is what? 3 meter per second squared. 3 meter per second squared, right? You now say its velocity. So they are asking you the final velocity when distance x is what? Is 24 meter, right? Now let me ask you here, which equation are we using? Is it the first, second, or third? Leave a comment section. Is it the first, second, or third? Which equation of motion are we using? First, second, or third? So let me hear from you. So now, how do you choose because some people don't know how to choose the equation of motion that go to you. Therefore, you have to know the 3 equation of motion from your head, right? So remember, the first one is what? V equals to U plus AT. That is what the first one, right? The second one is what? S equals to UT plus half AT squared, right? The third one is what? Is V squared equals to U squared plus 2AX, right? So from this equation of motion, there is how you go. From parameters given to you, that way you know what to use. Now, feel like they say she will calculate what? The final velocity. So yeah, this one don't have final velocity. So this one is at. Why? Because there's no final, because there's no what? Final velocity. So this one is already at. So is that here or here, right? Now, if you check very well, distance, they gave us distance, right? They gave us distance. This one does not have distance, so this one is art, this one is art. So the one we are going to focus on is v square equals to u square plus 2as, right? So it's going to be what? V square equals to u square plus 2ax. This is what you are using here. Hope you understand. Very easy. So let's substitute our values into the formula now. So you have v square equals to, my u is what? Is 0 square plus 2 times my a is what? Is 3 times my s is what? Is 24, right? So you have v square equals to 2 times 3 times 24. Let's check it. 2 times 3 times 24. Here we have 144. So here we have 144, right? What are you going to do here? Take the square root of both sides. So v equals to square root of what? 144. The square root of 144 is what? Is 12 meter per second. So the answer is what? Is D. Hope you understand. So now let's change value first. Let me change value. Now let us change here to 7. And let us change this one to 38 meter. It's okay. Go ahead and solve this one for me. It's very, very important. Go ahead. Question 3. Go ahead and solve this one for me. Just and go ahead and solve this for me. Very important. Pause the video. Go ahead and drop your answer at the comment section. Like what I said, over 95% of students watching this video will never do it. Right? This is the reason why they learn and they easily forget, because when you learn and you don't solve question by yourself, or you don't go or solve more questions, you usually forget what you have learned, right? But if you really want to read and understand very well, engage with the test, engage with what? With the videos. This is how to learn. Ask questions where you are what? Confused. Do you understand? So let's move to the what? Question 4. But then you solve it. So you have a car starting from rest, move with uniform acceleration. So remember when they say that a body starts from rest, when if you say a body starts from rest, my u is what? What is my u? My u is what? 0 meter per second, right? Then the acceleration, which is a is what? 6 meter per second what? Square, right? The distance cover in 4 seconds. So they ask to calculate the distance cover, right? Distance cover, which is x, distance cover in 4 seconds. Now t is what? 4 seconds, because it's 4 seconds. So which equation of motion are we going to use? So we are going to use this one here. X equals to ut plus half at squared. Why? You want to say should look for initial velocity, the time, right? By a, so we use this one here, right? So it will be s equals to 0 times 4, right? Plus half times my a. What is my a? 6 times my time is what? Is 4 squared. Do you see that? Remember, the other option will be 0. X equals to what? 0. Let's ignore it here. 4 squared is what? 4 times 4. 4 times 4, 16 times 6, 92 divided by 2. You have 48. So you have 48 watts. Now, what is the unit of seconds? Now, what is the unit of distance? Is what? Is meter. So let's look at what is called. So the answer is what? Is C. Answer is what? Is C. So this is a typical JAMB question. All these questions are from your JAMB past question. Do you understand? Are from your JAMB past question. So don't ignore these things. You see 1 or 2 of these questions in your exam. Even though they don't sit like that, they will just change what the value. So this is the reason why I've changed the value for you, so that you'll be able to know and master how to solve this kind of question. So we are going to work question 4. So now let me change the value here. Let us say here we have 12 meter per second square, right? That's in the 4th second. So go ahead. It can be what? 4 seconds. You are not changing time, but the acceleration is 12 meter per second square. That is it now. So we are done with question 4. Pause the video, copy it out, and solve it. Look at what question 5 is. That a fruit dropped from top of a tree 20 meter tall the time it takes for the fruit to reach the ground is. So they ask you to calculate the height. Do you understand? You have been asked to calculate what the height. No, it's not the height. They ask you to calculate what the time it takes for the fruit to reach the ground. So how do you solve this one here? You are still going to use equations of motion, right? Now we have to call motion we have to call linear motion, and we have to call motion under gravity, right? So the motion under gravity derive their formula from linear what motion. Do you understand? So linear motion use distance, while motion under gravity use the height, right? So the g is always constant, because when something is falling from height, is being acted upon by what a gravitational force, which is what g 10 meter per second square or 9.8 meter per second square, right? So g is always constant. So when a body is moving upward or downward, or moving under the influence of gravity, right? Now the acceleration is always constant. The acceleration is called the g. My a is what is g, which is what acceleration due to gravity, right? Which is now going to be 9.8 meter per second square or 10 meter per second square, depending on the value given to you. Do you understand? But if you use 9.8, if value is not be given to you, you can use 10, right? But it does not really mean you can use any one. You're still going to get, even though it's not the same answer, you're going to get close to the same answer. You're still going to see what the options. Hope you understand. So now let's look at something here. For the equations of motion, remember I gave you 3 equations of motion, right? So here we have v equals to u plus at, that is the first one. S equals to ut plus half at square, right? Here we have v square equals to u square plus 2ax. Now this is called linear motion. Linear what? Motion. Now when we talk about motion under gravity, that is upward, is moving vertical, right? Moving vertical is under gravity here. Now it can either be upward motion or downward motion, right? Now when it's downward motion, that is falling under the influence of gravity. Do you understand? So when we talk about free fall, that is falling under the influence of gravity. Do you understand? So it's moving in direction of gravity. So which is called downward motion. It's called downward motion. It's called downward motion. Downward motion. In downward motion, please take that here. In downward motion, my a is equal to what? To g, and my s is equal to what? H. Is it okay? Downward motion. Now a is equal to what? G, positive g. Why is it positive g here? Because it's solely under the influence of gravity. It's not acting against gravity. At the same time, we also have what called downward motion. We also have what called upward motion. Okay, in the upward motion here, my a is equal to what? Minus what? G. My s equals to what? H. Do you understand? So when I talk about motion under gravity, you need to ask yourself, is it downward motion or upward motion? If it's downward motion, then it's falling under the influence of gravity. If it's upward motion, that is opposing gravity. Now the reason why a is equal to minus g here, because it's opposing what? Gravity. Do you understand? So yeah, it's still going to be the same formula here, but I'm going to change all this one here. Do you understand? So anywhere you see your a, you put g. Anywhere you see your x, you put what? H. Do you understand? So it's going to be v equals to u plus gt. Do you understand? U plus what? Gt. Now from here, it's going to be v equals to u. Remember, yes, minus is going to be minus gt. You see that? So what difference here? Here is positive, here is what? Negative. Now positive because it's falling under the influence of gravity here. Upward means is what is opposing what? Gravity. Do you understand? So let's look at our s. Mine is going to be h. Do you understand? So anywhere I say as I put h, it's going to be h equals to ut plus half gt squared. Do you see that? Same thing here, going to be what? H equals to ut minus half gt squared. Do you see that? Then here we have this one here, v squared equals to what? U squared plus 2gh. Can you see that 2gh? Where you're going to be what? V square equals to what? U square minus 2gh. Now we still have about two other formulas under what? Motion under gravity here, right? Which I'm not going to touch here. I want you to go and check my last video on kinematics. Go and check the last video on kinematics. Go and check the last video on kinematics. This way I talk about this thing here, right? But because of this two questions we are going to solve, right? Should be two questions here. These two questions, we have to use this formula here. So let's look at what this question again. Look at what question again. Here we have a tree, a foot for a what am I saying? A foot drop from the top of a tree, right? So the height of the tree, which is h, is what? 20 meter. 20 what? Meter tall. So then after you to calculate the time it takes to reach the ground. So time it takes to what? Reach the ground, right? Remember, it's falling under the influence of gravity, right? It's falling under the influence of gravity. So my g is what? 10 meter per second what square. Do you see that? 10 meter per second square. So which one are we going to use here? Which one are we going to use? So that the initial velocity here, there must be initial velocity because the foot is resting, right? So the initial velocity is 0. So the initial velocity is always what? 0. It's okay. The initial velocity is always what? 0. Yes. The initial velocity is what? 0. Just and the initial velocity is 0 because it's only for a height. So there's an initial velocity here when the foot was not moving. Just and so it's 0. So which one are we going to use here? We have to use this formula here. Why? Because here we know our age, right? We know our age, the initial velocity, they say we should calculate time. We know our g, right? So because it's falling under the influence of gravity here, so we are going to use one here. So we're going to be h equals to ut plus half gt squared, right? That is it. So let's compute our values here. So here we're going to be 20 equals to 0 times t, right? Plus half times 10 times what? T squared, right? What happened here? What happened here? Going to be what? 20 equals to, remember, it's going to be 0. So going to be 2 going to 10 is what is 5. So going to be 5t squared, right? Make it t subject of formula here, right? When we make t, so t squared equals to what? 20 over 5, which is going to be what? 4, right? So we're going to be t equals to t squared equals to what? 4. So what are you going to do here? For me to write it here. So we're going to be t equals to square root of what? 4, which is what? 2. So the answer is 2, which is D. Right? The answer is 2, which is D. So now let's say here is what? Is 68 meter. So, right? 68 what meter? Go ahead and solve this one. Question what? 5. Go ahead and solve question 5. I've changed value. Change value, yes. Change value. So let's look at what the last question. Let's solve the last question. Pay close attention because it's a little bit trickish, right? A ball is thrown vertically upward from the top of a building with a velocity of 10 meters per second squared. Now, this is the top of a building, right? This is the top of a building, and a ball. Let me say this is the ball, and throw the ball, right? Throw the ball. Probably throw the ball to this point here. It will get to the maximum height. Do you understand? If it takes 4 seconds for the ball to reach the ground, so from here, now when you throw it up, you get to what? Maximum height. Right there. So for the ball to get to the down here, it takes what? The time it takes. Total time is what? 4 seconds, right? Yes, and I say, what is the height of the building? So what is the height of this building here? This is the height of the building. Can you see that? So yeah, the initial velocity here is what? The initial velocity is or 10 meter per what seconds. So therefore we need to calculate the height the ball travel when it's being thrown. Right? So throw here, you need to calculate the height. So now we have to use this formula here. The formula we have to use, we have to call upward motion. Upward what? Motion. And yeah, remember in upward motion, like it is acting against gravity, right? To calculate distance, here we have S equals to UT. Now we are going to use V square equals to U square plus 2 a minus what? Minus 2GX. It's okay. Please pay close attention here. This formula you are going to use here to calculate distance, to calculate distance here, to calculate the distance, like to calculate the height it went to when it's being thrown. Do you understand? So that's called upward what motion. It's called what? Upward motion. Now remember, my U, what is my U? My U is what? Is 10 meter per seconds. 10 meter per seconds, right? My velocity, my final velocity, when you get to the maximum height, it's going to stop. So my final velocity V is what? 0 meter per seconds. Do you understand? Remember, G is what? 10 meter per second square. So let's include the value here. The goal is to look for this guy. That is the goal. So here we have what? Here is going to be 0 square equals to what? 10 square. Here we have 10 square minus 2 times 10 times x, right? Do you understand? So what happens here? You're going to be 0 equals to 100 because 10 to our 2 is what? 100 minus, here we have 20x. Carry it to this other side, right? When you carry it to this other side, here we're going to be what? Minus what? Minus 100 equals to what? Minus 20 what? X. Can you see that? Minus 20 what? X. Divide both sides by what? 20. Do a calculation here. Then my x is equals to, my x is equals to what? 5 meter. Do you understand? 5 meter. So in saying that for the distance from the top of B to the maximum height is what? My x is what? 5 what meter. Now let's calculate from the distance from here to here. Do you understand? If you calculate distance from here to here, we subtract it from this one here. That's how we get what? The height of the video. Do you understand? So we have to use another formula here. Now remember, the reason why we use this formula here because it's upward motion. Remember I told you that upward motion is what? Is minus, right? Upward motion is what? Is minus, right? But downward motion here, the scope formula you're going to use is going to be x equals to ut plus half gt squared. Do you understand? X equals to ut plus half gt what square. Now why we use this formula here? Now, yeah, this maximum, this one at this point here where it stop here, this point here, the velocity, the initial velocity here, remember the initial velocity used to the stop up was what? 10, right? So when you get to the maximum height, it stop. So the final velocity will now be converted to what? Initial velocity going to get it down. Do you understand? So yeah, my initial velocity here going to be 0 meter per seconds. Do you understand? My time it takes to reach this ground here is what? 4 seconds, right? My g is what? 10 meter per second what square. So do what you want to use it. Your s is equal to what? 0 times 4 plus half times 10 times 4 raised by 2. Just that this will cancel out this, which go to make it 5. So here we have x equals to 0. Remember 0 times 4 is 0. So it will be 5 times 16 because 4 is about 2. 4 times 4 is 16. So what I got to get here? 5 times 16. Here we have what? 80. Here we have what? 80. See 80. Now the time is what? The time is 3. Now because you already have the option here, so the time is 3. So yes, 3. Please change the time. The time is 3. The time is 3 from the textbook. So I made a mistake from that time. Just so my time is 3 seconds. 3 what seconds? So you're going to be what? 3. Just now we should square, yeah. So you're going to be what? 9. So 5 times 9 is what? Is 45. Here we have 45 what? Meter. Just now. So from here to here is what? Like the total distance is what? Like from here to here is what? 5 what? Meter. 45 what? Meter, right? 45 what? Meter. Just a 45 meter here. So what is the height of the building? They said the height of the building. So the height of the building, which is H, is going to be what? 45 minus what? 5 meter. It's okay. So which is going to be what? 40 meter. So 40. Here we have 40 here. This is what? This is the answer here, right? This is the answer. So what I want to do here, let me change it to what? To 15. Right? Let me change it to 15, and let me change it to 6 seconds here. Just so go ahead solve this question for me. Leave your answer at the comment section. If this video is helpful, please leave a comment section that this video is helpful. See you in my next video.